So we're going to look more closely at the sine and cosine graphs, specifically at the amplitude and the period of these functions. Now, just like with our parent functions, these sine and cosine, even tangent, cosecant, secant, cotangent functions all have a general formula, and they're given right over here. We're only going to look at sine and cosine today, so we have a cosine k theta plus c plus h. Now the h and k are a little bit different than the h and k in our previous formulas because they're situated differently, obviously. Again, today we're only going to look at the amplitude and the period changes. So as you look, A reflects what's called the amplitude. It acts kind of like a vertical stretch. It multiplies all the y values. K has to deal with the horizontal stretch, all right? And it deals with the period of the function, or how long it takes for one cycle of that graph to repeat. The period itself is equal to 2 pi over k, or since we haven't gotten into radians yet, 360 degrees over k. Actually, we have gotten into radians. Let's take a look at first example. And we'll do this in degrees just to get you kind of used to what's going on. All right. We're going to go by degrees. So we'll go 0 here, 90, 180, 270, 360. And this will be one period of sine because the graph will repeat in 360 degrees. So usually sine goes between 1 and -1. And we know the sine value at 0 is 0. The sine value at 90 is 1. Sine value at 180 is 0. The sine at 270 is -1. And the sine at 360 is 0. And just like the previous day, we graph this, kind of connecting the dots, and we get this curve guy like that. Next, we'll take and graph 3 sine of theta. Now, we know that the amplitude in this case is equal to 3, so that should multiply all the y values by 3. 0 times 3 is 0. Let's call this 1, 2, and 3. And 3 times 1 is 3, so this is going to go up here. 3 times 0 is 0 again. 3 times -3, there's -1, -2, -3. And it's going to go here. 3 times 0 again is 0. Graphing once again, notice I'm only affecting my y values. My period's going to stay the same. It's going to increase and decrease a little steeper. There we have it. So now our a value is going to be a -4. Let's change colors. We'll go to whatever color this is. We're going to multiply all the y's by -4. So 0 times -4, -4. 1 times -4 is -4. Put this down here. 0 is 0. -1 times -4 is +4. So this is going to go all the way up here. And 0 times -4 is 0. Graphing once again. I see the y's have all been multiplied by a negative, which means this reflects over that x-axis. And those are my 3 different shapes. All reflect a multiplication of the y value by a certain number. Let's move on to the next example. Now in this case, what's going to happen is we're going to be messing with the k value, in other words, the period. K in this first term equals 1. Whenever it's 1, there's no change. K in this case is 2. Therefore, if my period is equal to 2 pi over k, then my period is equal to 2 pi over 2, or pi. Period in this case, k is equal to 1/3. So therefore, my period is 2 pi over 1/3, or 6 pi. And in the last case, my k value is pi, and my period is 2 pi over pi, or 2. So I'm going to graph each of these on a separate set of axes. let's take and graph this first one. We'll go from 0 to 2 pi in this case. So we go 0, 2 pi, and put our pi here, pi over 2 here. Notice I'm marking all the axes again. And 3 pi over 2. Graphing cosine. Cosine at 0 is 1. Cosine at pi over 2 is 0. At pi is negative 1. At 3 pi over 2 is 0. And cosine at 2 pi is 1 again. We graph it, and this looks exactly like the other day. So in this case, once again, I want to talk about these numbers on the bottom. We call these our interval numbers, and these intervals are basically consistent as to where my sine and cosine values would be 0 and 1, so they're on the axes. But when I take and change the value of k, that means I'm changing my period. That means the zeros and ones happen at different places now. So we're going to look at how we're going to find those intervals in just a sec. In this problem, I'm going to take now and graph a period of cosine, which is now going to happen between 0 and pi. To get my intervals, I want to take my period and divide it by 4. So in this case, my period is pi, and I divide that by 4, and that's pi over 4. So every pi over 4, I'm going to put a new interval. So that's pi over 4. Add another pi over 4 to that, and I get pi over 2. Add another pi over 4 to that, and I get 3 pi over 4. Add another pi over 4 to that, and I get pi. And again, this graph is going to be the exact same. I've just changed all my x values by that new multiple. So you'll notice it's the same graph. Likewise, if I go from 0 to 6 pi, I need to adjust all my intervals, and my graph will still look the same. But if I want the intervals, I take my period, which is 6 pi, and I divide that by 4, because there's 4 quadrants to the circle, giving me intervals of 3 pi over 2. So if I add 3 pi over 2 to the first value, I get 3 pi over 2. Add 3 pi over 2 to that, and I get 3 pi. Add 3 pi over 2 to that, and I get 9 pi over 4. Or 9 pi over 2, excuse me. The graph's then going to look the same. It's just all the zeros and ones happen at different points than they did in the parent function. Lastly, if I go from 0 to 2 and find my intervals from 0 to 2, I take my period, which is 2, divide that by 4, representing the 4 quadrants, and I get intervals every half. So I go to a half, 1, 3 halves, and 2, and I graph the cosine function. And the cosine function is going to look similar to what we've been doing. So all the same graphs, they just happen at different points in time based on the period change. Now we're going to link a couple of these together. In this case, our a value is equal to 3. Our k value is equal to a half. Therefore, our period equals, let's go 2 pi over the k value. So our period is equal to 4 pi. So I'm going to graph one period of sine, and I know that period is going to happen every 4 pi. To find my intervals, I take and divide my period, which is 4 pi, by 4, representing the 4 quadrants. And I get intervals every pi. So I have pi, 2 pi, 3 pi, and 4 pi. Now what I'm going to do is I'm going to list my amplitude, which is going to go from 3 to negative 3. and then just graph sine from here. I know my sine value normally at my first quadrant point, or on the positive x-axis, is 0. Then it goes to 1, 0, -1, and 0 again. So here's my graph. I have all my intervals correctly stated, and my amplitudes are labeled correctly. If I wanted to check that point there at 2 pi, I'd look and see 3 sine of 2 pi over 2, which is equal to 3 sine of pi. I know the sine of pi, which is the y value, is 0, and 3 times 0 is 0. So my point's checked out. Let's move on to the next example. So again, in this case, I have an a value equaling -5. I have a cosine value of pi over 2 times theta, and that means my k value is equal to pi over 2. My k value is pi over 2. My period is equal to 2 pi over the k value, which is equal to 4 in this case. Now, given that, what I'm going to do is I'm going to take and lay out my axis again. This time my period will equal 4 over 4, and I'll get intervals. Oops, I'm sorry, that was supposed to be intervals. So I get intervals of 1. So if my period goes from 0 to 4, then I have intervals of 1s. Those are all the unique points where I'm going to get values of 0 or 1. Now, my amplitude is 5, so I'm going to go from 5 to -5. And in this case, normally my cosine value would have a y value or an amplitude value of 1, but since we're multiplying all my y values by -5, my first value is a negative. Then I go to my first axis, or my positive y-axis, and I get a value of 0, 1, 0, -1, and here is my reflected cosine function with the new intervals built in. So we're going to switch gears a little bit, and we're going to actually write an equation now of a sine function with a period of 540 degrees and an amplitude of 2. So if I know the period is equal to 360 over k, and I'm using 360 this time because they give me degree value here, then I know my period, which is equal to 540, equals 360 over k. Therefore, k is equal to 360 over 540. I know 90 goes into both of those, 4 times up top and 6 times up on the bottom, which goes to 2/3. And that's going to be my k value. I also know I have an amplitude of 2, so I can say then that y is equal to 2 sine, and I need my k value of 2/3 theta. And I'm done. Next example. I'm going to write a cosine equation with an amplitude of 7 and a period of pi over 4. So now we're working in terms of pi. Period, once again, is equal to 2 pi over k. So now I have pi over 4 is equal to 2 pi over k. I then know that k is equal to 2 pi over pi over 4. And in this case, that's going to be equivalent to 8. Now I can write my function. I can say y is equal to 7, which is my amplitude, times the cosine of k times theta. And there we have it. Now, this problem is just a little bit different in that we're given the equation of a graph, and we want to, or I'm sorry, we're given a graph and we want to write its equation. And they're telling us off the bat that this is a sine equation. So we know what we're looking at. Now, normally sines would come up like this and then come down. But this one doesn't. All right, this is going to start by going down. Let's get back to that slide. So I must know then that instead of going from 0 on up, it's going from 0 down. That means I'm going to have some y equals some negative amplitude. And I look at to see how high it goes and how low it goes, and it varies between 3 and negative 3. So this must have an amplitude of 3. And I'm going to put my sine value here. Oops. The next thing we have to notice is how long does this graph take to repeat? Well, it goes down, up, down, and repeats over this period of time. So my period in this case is equal to pi. I need to find my k value. I know that the period is equal to 2 pi over the k value. Therefore, k has got to equal 2. So I fill this in here, and this is the equation of that graph. Again, it's important that they tell us if it's a sine or a cosine graph, at least at this point. So that's going to do it for the day. I want you to answer these first 2 questions, and then I'll slide this down and you can get the third question. Here you go. So you're going to answer those 3 questions, and we'll see you tomorrow.